Hi, this is a short video produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. We are still looking at our dynamic universe here, but this time we're looking at forces, specifically energy and power. So here we have a typical exam question. There is a frictionless flat surface and on it sit four masses as shown. A constant force is applied in the direction of the arrow. Then we have five choices. The tension in the chain is greatest between the camel and car, least between boat and bus. Greatest between boat and car, least between car and camel. Greatest between the bus and the boat, and least between camel and car. The same in all the chain sections, or least between the boat and bus, and greatest between the car and boat. So many options there, and they are quite long worded, and that can often throw you off, but stick with it and don't let your brain confuse you. Our approach is the same as ever. Read the question closely and pick out the things we're being asked about. We're just being asked where the tension in the chain is greatest. Look at the options, see if there's anything we can ignore. Well, option D does feel like it might not be right, but I wouldn't ignore it yet at this stage. Recall that we're in the aerodynamic universe part of the course, so we can ignore the rest. Read the question again slowly in your head and avoid overcomplicating things. This is one that can be quite easy to complicate because there are so many combinations of things going on. But I would suggest a pen and a bit of paper just to underline maybe camel, car, boat, bus, let's say, in option A, just so that you can focus on the key parts. So this question is talking about forces, and clearly there are masses involved on the screen: the bus, the ferry, the car and the camel. So we just need to think about the situation. It says the force being pulled is constant on the end of the chain, so we don't need to worry about that changing. And in the real world, we can think if we applied 1 Newton to a string attached to a feather, well, it would fly off easily, wouldn't it? If you attach the same string and pulled with a force of 1 Newton on a 747 jet plane, you'd probably break the string, right? The plane wouldn't move. So what's the difference between those two? Well, the difference is their mass. The more mass something has, the harder it is to accelerate with a constant force. So the tighter the string or chain will be between those two things. So what do we have here? Well, if we apply a constant force, then you can see the masses that have to be pulled at various sections. At the very end of the chain, we're just pulling on the camel. Before that, we're pulling on the car and the camel. And before that, we're pulling on that boat, the car and the camel. And then finally, we're pulling on everything. So we can see that at each of these stages, the masses get bigger, and so the tensions in the ropes will also increase in size. So that should help us answer the question. From what we've just seen, we know that the tension here is going to be bigger than the tension here, because at this point we are pulling on all these forces, and at this point we're only pulling on the camel. So let's check the answers. Greatest between the camel and car? Well, no. Greatest between the boat and car? No. Greatest between the bus and the boat? Well, that's a yes. And least between the camel and the car? Well, that's also a yes. So we don't really need to go any further. We know now that C is a likelier answer, and in fact it is. So things to note. In questions like this, there will typically only be 4 weights, so that there'll be at least 5 answer options available, so that's something to look out for. Watch for changes in wording, that they don't throw you off. You'll see in the last they flipped greatest for least. Don't let that put your brain off. And here are some more examples and questions which you can try out on my Hi page at hi.page/physics/FYSX. Give them a go there, the answers are also available. And well done, we've just tackled another Paper 1 Higher Physics question. So thanks for watching, and don't forget to subscribe.